All right, problem 21. John knows the measure of all the angles add up to 360, but is unsure how to solve the problem. What equation did Joanne give him to help him out? Well, we know all these angles add up to 360. 1, 2, 3, 4. These 4 angles add up to 360. So all I'm going to do to write this equation is simply say that the sum of these angles is equal to 360. So 360 is equal to this plus this right here plus this one, 2x minus 45. Now, some of you may be tempted to solve. You can, but I won't, because we don't have to. All right, so we're just going to leave that alone. Write the equation. Boom. There's the equation. Moving on. The length of the rectangle is 2 less than 3 times the width. Write the equation that can be used to find the width of the rectangle. First thing I'm going to do, length of the rectangle is 2 less than 3 times the width. So the length is going to be 2 less than 3 times the width. Here's 3 times the width. Here's 2 less than that. So whenever we use length, we can take this and put it in to get a width. The area of the rectangle is 42. Area is 42. We know the area is length times width, and that's equal to 42. This is where it's going to get a little crazy. Instead of length, I'm going to use this bad boy right here. So I've got 3w minus 2 times w is equal to 42. Very simple. As long as you can grab this first equation, probably going to be all right. Again, they're not asking us to solve anything, just asking us to set it up, so we're going to leave it right there. One side of an equilateral triangle is 3x plus 1. Write an expression that represents the perimeter. Hint, draw a picture. Here comes the picture. Not bad. Not bad. I've got 3 sides. They are all the same. All right? So I've got 3x plus 1. That's this side. And then I have 3 total. So I'm just going to do it just like this. Your equation may end up looking something more like this, because you say that there are 3 sides, they're all 3x plus 1, so I'll add them together. Both of these are fine. You can even say 9x plus 3 if you get a little crazy with it. All right, next problem. Solve the following equations. We just got a few more of these bad boys to nail out. 2 over 3r. Now you'll notice this one a little bit different from the ones we did earlier, because r is out to the side, and on these you had that x or whatever inside that fraction. But you can attack it the same way. I would get rid of the denominator first, multiply both sides by 3, cancels the denominator over here, leaving you just at 2, and then 8 times 3 is 24. I'm going to pull that 2 out, and I'm going to get r is equal to 12. Boom. All right, next one. Pull that 21. It's the only thing really holding back our p. We got negative p is equal to negative 17. Be very careful here with that negative 17. And the negative, don't want to drop that. We got to pull it off. So I'm going to divide everything by negative 1. And we will get p is equal to positive 17. 26. F, same deal. Pull that 7 from both sides. Negative f is equal to negative 13. Divide both sides by negative 1. And we'll get f is equal to positive 13. All done. Last one. Take the 3. Distribute the 3. 3q minus 27. This side stays the same. Add that 27 to both sides. I'll get 3q is equal to q plus 28. And you may ask, Coach, I apologize, Mr. Murdoch, why did you do that? Why did you move the 27 over? It's because I want my q's to stay positive. I don't want to subtract the 3q over here. I want to subtract that 1q over here. And since I know my q's are going to end up on the left, I'm going to make sure my numbers end up on the right side of that equation. Always trying to keep my variable positive makes my math just a little bit easier. That's the review. Good luck tomorrow.